Today we are going to see the problems which are related with flange section. So already these 5 problems are given to you and we have to solve these problems. So now we have first problem. Calculate the moment of resistance of the flange section for the following data. So we have given this given data. So we have BF 1350 mm. So thickness of slab we have 120. Then we have capital D 600, D dash 50, and BW 300 mm. So now if we will draw the diagram and if we will show the forces in it, then we can have this. So we have 6 bars. So now BF means we have this is top 1350. Then we have depth of flange means depth of slab 120 millimeter. We have overall depth. So we have this value that is 600 millimeters till bottom. If we will subtract effective cover, we will get 550. And again, we have given BW means we have given this value 300 mm. And then we have 6 bars of 25 torque. So 6 bars of 25 torque. So these values are given. We have shown in the diagram. So now we will have D, which is equal to capital D minus D dash. Capital D we have given 600 minus D dash is 50. So we will get this value as 550 millimeters. We have given AST, that value is given 6 bars of 25 torque. So 6 into 5 by 4 into 25 square, which is equal to, we have this value 2945.24 millimeter square. Then we have given FCK 20 Newton per mm square. Then we have given Fy, that is 500. Now we have to go for analysis. So whenever we will solve flange section, assume neutral axis in flange. Assume neutral axis in flange. And then we have for all Cu equal to Tu. And we will get this value that is 0.36 FCK XUBF, which is equal to 0.87 FYAST. And when we will put these values, so we have 0.36 FCK is 20, XUBF is 1350, which is equal to 0.87 Fy is 500, and AST is given 2945.24. And if we will calculate, we will get value of XU. I have calculated 131.81 millimeter. So this value is greater than depth of flange, and therefore assumption is wrong. Therefore, assumption is wrong. What does it mean? That means my neutral axis lies in flange. So neutral axis lies in flange. Sorry, lies in web now. Now web, we have again two conditions for web. We have first condition, that is that we will consider, we have 3 by 7 of XU is greater than DF. And if we have this condition, then our flange have constant stress, which is 0.446, that is 0.45 FCK. And then if we will use Cu equal to Tu, then we have formula 0.36 FCK FCK 0.36 FCK XU. Now it becomes BW plus we have stress 0.45 FCK, area we have BF minus BW into depth DF, and which is equal to 0.87 FYAST. Now calculate this 0.36 FCKBW. If this is not satisfied, then next we require this 0.87 FYAST. Also calculate this separately. Now by this, if I will put the values, what we have made over here, we have considered two parts separately in this. That already we have explained in the class. One part we have this as rectangular beam having value BW, and then remaining part, so that is total BF minus BW, that will be flange push. So now if we will write values, then we have 0.36 FCK, we have 20, XU, BW we have 300, plus then we have 0.45 FCK is 20. This is stress. BF is 1350 minus BW is 300. Depth of slab is 120, which is equal to 0.87 Fy, and value of AST is 2945.24. And by solving this, we will get value of XU. Now I will directly write value of XU we will get. So I got this value of XU, which is equal to 68.14 millimeters. So it shows 3/7 of XU is again less, which is less than DF, and therefore again our assumption is wrong. Assumption is wrong. But this assumption in wave that is correct, but 3/7 of XU is not less than 3 DF, and we have then go for third portion, and in that third portion we have 3/7 of XU. 3/7 of XU is less than DF. And then in this case, we have to use value of YF, which is equal to 0.15 XU plus 0.65 DF. And then we are going to get value for this. So now, if we will put a value of DF over here, then we will get it as equal to 0.15 XU plus 0.65, and DF we have 120. And by this, we can have this value of YF, that is 0.15 XU plus we have this value that is equal to 78. And now if we will write equation Cu equal to Tu, then we have this equation 0.36 FCK XU BW, this part is as it is, plus 0.45 FCK, this stress will be as it is, into this also as it is, BF minus BW. Change we have over here. Here we have YF, which is equal to 0.87 FYAST. And now if we will put the values in these equations, we will have 0.36, FCK 20, XU we have to find, BW is 300, then plus this we have one bracket, plus then we have 0.45 FCK, so FCK we have 20, BF minus BW, so BF we have 1350, BW we have 300, YF just we have calculated 0.15 XU plus 78, and then equal to 0.87. I already told you, calculate this value. So you need not require to calculate every time. 2945.45. And by solving this equation, we will get value of xu, and that is equal to, I got it as 152.08. And this value is less than xu max, which is 0.48 in, sorry, 0.46 into 550. So it comes around 250. So I have not calculated that value, but we can come to know this is less than 0.46 into 550. So our assumption now, this assumption is correct. That is 3/7 of xu we have less than df. And therefore, now we will find mr for this. So we have mr that is equal to 0.36 FCK XU VW. So this is a rectangular portion. D minus 0.42 XU plus now remaining flange portion 0.45 FCK. Then we have area BF minus BW now into YF into D minus YF by 2. This is lever arm. And now substitute values of the equations. Values in this equation, you will get moment of resistance. So we have MR, this is equal to 0.36, FCK 20, XU we have 152.08, BW we have 300, D we have 550, minus 0.42 into 152.08. This is of rectangular section plus 0.45 FCK is 20 into 1350 minus 300 YF. Now we can find, if I will put value of XU over here, 0.15, XU is 152.08 plus 78. And by solving this, we will get value of YF 100.81. And this value should be less than DF. And we have this. So into YF 100.81 into D is 550 minus 100.81 divided by 2. And by solving this, we will have this value. First part we will have 159.69 into 10 raised to 6 plus 475.94 into 10 raised to 6. And so adding this, we have 635.63 into 10 raised to 6 Newton millimeter. And from this we are going to get value of MR, which is equal to 635.63 kilonewton meter. So we have values of moment of resistance is in this fashion. So this is our first problem. Now we will switch over to the second problem. So we have given moment of resistance, given data we have. So diagram we have given. Now I will directly write value over here. So we have these values. So this value we have 1250. DF we have 120. Overall depth 550. Then AST we have 6 bars of 22 torque. And then we will write here small d 550 minus 40. So it goes to 510 millimeters. Then we have AST 6 bars of 22 torque. And we will have this value equal to 2280 0.8 millimeter square. We have FCK 25, 25 and FY 415. Fy 415 mm square, Newton per mm square. Now again we have first assumption. Assumption. Neutral axis lies in flange. Neutral axis lies in flange. And then we have Cu equal to Tu. So Cu equal to Tu. And then we have this value 0.36 FCK XU BF equal to 0.87 FY AST. And then put the values 0.36 into 25 into XU 1250, which is equal to 0.87 FY 2280.8. And by using this, we are going to get value of XU, which is equal to 73.20, which is less than DF. Therefore, assumption is correct. Therefore, assumption is correct. And then we can find value of MR directly here. So we can have MR that is equal to MR equal to 0.36 FCK XU BF. This is force minus in bracket D minus 0.42 XU. This is lever arm. And then put value 0.36 FCK 25 XU 73.2 BF 1250 into D 510 minus 0.42 and XU value is 73.20. And by using this, we are going to get a value of MR 394.67 into 10 raised to 6 Newton millimeter. And therefore, value of MR is equal to 394.67 kilonewton meter. So we have this will be our second problem, which are related with your flange section. Now we will switch over to the third problem. We have third problem, calculate the moment of resistance. Now we have given data. So we have given all this. Now you can write these values over here. So I will directly go to the problem. So small d we have 600 minus 40, which is 560 millimeters. And then we have AST. AST equal to 8 bars of 25 torque. And I got this value. 8 bars of 25 torque, 3927 millimeters square. So we have 3927 millimeters square. This is 8 bars of 5 by 4 into 25 square. Then FCK is given 20 MPa and Fy is 500. Unit are important, MPa. So now again we have assumption. Assume neutral axis lies in flange. So we have assumption. Neutral axis lies in flange. Now if we will see it carefully, then steel is very large. So our this criteria will not be satisfied. So you can go actually directly with in wave also. So 0.87 FYAST. And then by substituting values, we have 0.36 into 20. XU we have to find out. BF is 1500 equal to 0.87. FY is 500 into AST is 3927. And by this, we are going to get value of XU, which is equal to 158.17 millimeters. So our assumption, which is greater than DF, which is given as 100 millimeter. So our assumption is wrong. Assumption is wrong. So that means our neutral axis lies in web. So here we need not require to assume. So here we can directly write that is neutral axis lies in web. Now here we have assumption. Assume 3/7 of XU is greater than DF. And due to this, we are going to get constant stress 0.45 FCK in flange. So we will write Cu equal to Tu 0.36 FCK XU. Now this is BW plus stress we have 0.45 FCK constant in bracket BF minus BW into DF. This will be area, which is equal to 0.87 FYAST. And now if we will put values in this equation, 0.36 into 20 XU BW we have 300 plus 0.45 FCK we have 20 into BF minus BW 1500 minus 300 and DF we have into 100, which is equal to 0.87. FY we have 500 into AST 3927. And by this we will get value of XU, and that is equal to 290.85 millimeters. 290.85 millimeters. But this value is greater than XU max, which is 0.46 into 560. And we have this value that is equal to 257.6 millimeters. So we have to consider XU that is equal to XU max. So if we will go XU equal to 257.6 millimeters. If we will calculate, this is fixed, 3/7 of XU. Then we have 3/7 into 257.6. And if we calculate this value, 3/7 of XU, we have 110.4 millimeters. 110.4 millimeters, which is greater than DF. And therefore, our assumption is correct and our stress is constant in flange. And therefore, we will get MR, this is equal to 0.36 FCK XU BW, this is rectangular portion, D minus 0.42 XU plus 0.45 FCK stress area BF minus BW into DF equal to 0.87 FYAST. Sorry. Into DF, we are finding actually moment of resistance. Just I will have this into lever arm, and then we have lever arm that is D minus DF by 2. And then by substituting values in this equation, 0.36, we have value of FCK 20. XU is XU max 257.6. D we have, sorry, into BW first. So into BW, we have 300. Into D is 560 minus 0.42 into 257.6 plus 0.45. FCK we have 20 multiply by BF 1500 minus BW 300 into DF we have 100 into D 560 minus DF by 2, 100 by 2, and from this we will get value of MR, that is equal to 251.39 into 10 raised to 6 plus 550.8 into 10 raised to 6. And from this we will get 802.19 into 10 raised to 6 Newton millimeter, and therefore MR equal to 802.19 kilonewton meter. So this is third problem. Now if we will go to the fourth problem, then we have this as given data. So all values are given. So I will just put values first. So AST we have AST equal to 3694.21 millimeter square. Then D we can have small d I will calculate, which will be 525 millimeters. Now we have first neutral axis in flange. Now I will directly put the values 0.36 FCK we have 25 into 130 FCK. XU we have to find. BF is given 1100 equal to 0.87. FY we have 415. AST we have 3694.21. And we will get value of XU, which is equal to 134.74 millimeter, which is greater than 110, which is DF. And therefore assumption is wrong, and therefore neutral axis lies in web. And in this, now we will go with first assumption, that is 3/7 of XU we have. So assume 3/7 of XU is greater than DF. And then we will have, now I will not write formula, 0.36 FCK XU BW is 230 plus 0.45 FCK is 20 BF minus BW 1100 minus 230 into DF. DF is 110, which is equal to 0.87. FY is 415. AST is 3694.21. And by this, we are going to get value of XU, which is equal to 228.31. 228.31 millimeter. So now we have 3/7 of XU, which is equal to 228.31, and this values gives us 97.85 millimeters, which is less than DF, and therefore Again, assumption is wrong. And then we have 3/7 of XU. So we have 3/7 of XU is less than DF. We have assumed 3/7 of XU greater than DF. Our assumption is wrong and our DF is greater than 3/7 of XU. And then we have to go for the next. Now here also we have to check this value, that is 0.48. We have to also check that value. This is less than 0.48 into 525. So actually we have to check this value. So I will just check this. 0.48 into 525, it comes 252. So that is okay. And then we have last, that is, so YF we have to consider now. So YF we have 0.15 XU plus 0.65 DF. And then if we will put 0.15 XU plus 0.65 and value of DF, we have 110. And from this we will get 0.15 XU plus we have 71.5. And now I will directly write formula. We have 0.36 FCK XU BW is 230 plus 0.45 FCK BF is 1100 minus 230 into 110, which is equal to 0.87. Fy is 415 and AST is 3694.15. And then we have value of XU. Now actually we need not require to check 3/7 also, because this condition should be satisfied. 179.22. And if you calculate also 3/7 of XU, and this comes less than 110 mm. And therefore we have to find MR, and we have value of MR that is equal to. Now again directly I will write 0.36 FCK XU is 179.22. In bracket we have 525 D 0.36 FCK XU. So that B is remain. That also we have to write. So B we have 230 into D 525 minus 0.42. XU is 179.22. Then we have plus 0.45 FCK BF minus BW into DF we have 110. In bracket D we have 525 minus point minus YF by 2. And if we will put the XU over here, YF we got 98.38. And then we have minus 98.38 by 2. And I will directly write over here, MR we will have equal to 533.36 kilonewton meter. So just go through this, and then we have last problem. So we have that problem. So given data we have. Now I will directly go neutral axis lies in flange and still is less. So definitely we are very close. We will check if 0.36 FCK XU into BF, which is equal to 0.87 Fy And AST we have 1884.96. And from this we will get value of XU which is equal to 63.27 millimeters, which is less than 120 mm, which is our DF. And therefore, assumption is correct. And we have MR equal to 0.36 FCK XU BF into D we have 600 minus 50, 550 minus 0.42 XU. And from this we will get MR, this is equal to 429.19 kilonewton meter. So likewise we have to solve these problems of flange section. So now we will stop here only. Thank you.